this is the new batch. This course is common to all the branches, including CSE. Mainly for CSE students, linear algebra, calculus, and probability they have to attend in this course. In engineering mathematics and discrete mathematics, there are total 7 topics. 3 topics are covered in this course, and remaining 4 topics are discrete mathematics. We will cover in the next course. That course I am going to start from May 1st week onwards. Okay. Now, today I would like to start linear algebra. In linear algebra is common to all the branches. All the branches. Okay. Now, I am going to explain from basics onwards. You need not worry about anything. Okay, I'll start from matrix onwards till in depth diagonalization we are going to complete. Okay, in linear algebra. So you need not worry about the courses designed for GATE or ESE. Each and every point we are going to cover in this course. Okay. Now, Abhishek, in this course is not discrete. This is purely engineering mathematics course. Discrete mathematics I am going to start from May 1st week onwards. That is for CSE. Okay. Yeah, this course is common to all the branches. Now, let me explain the topics which I am going to cover in this chapter in matrix theory. Okay. Just I am giving my contact details. You can send me message if you have any queries. I'll join you in the group. Okay. Now, let me explain the concepts which I am going to cover. Now, linear algebra. Now, Rohit, I'll explain everything. Okay. Wait, let me explain mainly the concepts of linear algebra. One is basics, determinants, determinant and its properties, Faizan, no problem, it is mathematics, you can understand. Now, basics, determinants and rank and its properties, system of equations, basis and dimension, eigenvalues, and eigenvectors, Cayley-Hamilton theorem, diagonalization, 1 minute, observe. There is no lag. Rahul, I'll take care about everything. You don't worry. Just observe. Even though you are a diploma student, you can understand. The course is helpful for all the branches. Duration of the class is 2 hours, 9:30 to 11:30. Let me introduce the concept. Anandji, I'll recommend when it is required. Okay? First, attend the class, follow the course. Definitely you will get the confidence, 100%. Now, I have given the contact details. You send me the message, I will join you in the group. Okay? Concentrate here. So mainly basic concepts of matrices, classification of matrices, types of matrices, trace of matrix, what are the properties of transpose, right? Suraj, after completion of the course, after completion of the class, you can download the notes, PDF. Okay? Now, determinant and its properties, rank and properties of rank, basis, dimension, basis and dimension and nullity. If you understand rank and basis and dimension concept, you can understand eigenvectors properly. If you understand the concept of rank and the concept of basis and nullity, you can understand how to identify independent eigenvectors and linearly independent eigenvectors, especially. Okay, now especially properties of eigenvalues and properties of eigenvectors, application of Cayley-Hamilton theorem and diagonalization. These are the main core concepts of linear algebra. You can understand these concepts only when if you have idea about rank and dimension. Okay, Mohammed, I'll give the guidance. Which course first you have to attend, next which course you have to follow. I'll explain clearly. Okay, let me start with the basics. Now, what is matrix? What do you mean by matrix? Generally, matrix is nothing but array of elements, arrangement of elements, or rectangular array of elements is known as matrix. Generally, we will say a set of mn numbers, matrix. Today is our focus on only basic concepts and problems on basic concepts. Okay, now matrix, a set of mn numbers can be arranged in a rectangular array of m rows and n columns. M rows and n columns is known as M cross n matrix. Vijay, definitely I'll give the DPP. Don't worry. First you concentrate on the content. Sir, a set of mn numbers can be arranged in a rectangular array of m rows and n columns is known as M cross n matrix. For example, I have given 24 elements. Okay, I have given 24 elements. 24 elements can be arranged in a rectangular array of 24 rows and 1 column. 12 rows, 2 columns. 6 rows, 4 columns. Okay. 2 rows, 12 columns. And 1 row, 24 columns. Like that, different possible arrangements we have. Based on the arrangement, we can call it as what type of matrix it is. Suppose if you arrange 24 rows into 1 column, you can call it as 24 rows and 1 column, 24 by 1. Understood? Suppose if you arrange 6 rows and 4 columns, we can call it as 6 by 4 matrix. Dear students, please concentrate on the content. Okay? Because comment box you have to use only for queries. Okay? This is the first class. Please concentrate on the content. Now, matrix is nothing but array of elements. Okay. Rectangular array of elements is okay. Matrix can also defined as arrangement of elements, arrangement of vectors. Concentrate please. Matrix is not only array of elements but also arrangement of vectors. You have to think in that direction. Sir, how matrix is arrangement of vectors? How matrix is arrangement of vectors? Kamlesh, my voice is low. Please concentrate on the content. How matrix is arrangement of vectors? Simple logic, I'll explain. Generally, a set of mn numbers can be arranged. M rows and n columns is known as M cross n matrix. We are going to represent like this. Matrix A equal to, generally matrix is represented by capital letter. Now, A11, A12, A1n, A21, A22, and so on A2n, AM1, AM2, and so on AMN. Observe. Here, first row consisting of n elements. Second row consisting of n elements. Mth row also consisting of n elements. Okay. Now, you can say that this row, first row, R1, consisting of n elements. Therefore, R1 is a row vector of dimension n. Consider here. A row vector of dimension n. So dimension is nothing but number of elements in that vector, number of components in that vector. Okay, number of components in that vector is known as dimension of that row vector, R1 with the dimension n. Sir, what about second row? Complete second row is a row vector of dimension n. Similarly, mth row is a row vector of dimension n. There are how many row vectors in this matrix? m row vectors. That's why m rows. Sir, how many column vectors we have? Concentrate. How many column vectors we have? First column, second column, third column, nth column. So n column vectors we have. That's why m row vectors with combination of n column vector, that gives us m cross n matrix. So with reference to row vectors or with reference to column vectors, you can define your matrix as arrangement of vectors is also known as a matrix, because you are going to study a concept known as rank. What rank refers? Sir, what is rank of the matrix? Rank always refers number of independent vectors. If your matrix is arrangement of vectors, in that arrangement, how many vectors are linearly independent declared by rank? That's why, yeah, a set of mn numbers can be arranged m rows and n columns is called m cross n matrix. That is the basic definition. You have to understand in the way that matrix is not only array of elements but also arrangement of vectors. Catch my point? Every column is referred as column vector. Every row is referred as row vector. Okay? Hello, element is different, vector is different. Don't misunderstand the concept. Chaudhary, I will come to independent. What is dependent? Mukul, I will explain. What is combination of row vectors? What are the combination of column vectors? Everything I will explain when we are going to study about rank of the matrix. So first I am giving basic idea. Okay? Now, so you have to understand in the way that matrix is not only array of elements. It is not only array of elements but also arrangement of vectors. Keep in mind in that manner. Okay? So array of elements and arrangement of vectors. Dimension means number of elements in that column is called dimension of the column. Suppose if you write one vector like this, I cap plus 2j cap plus 5k cap. What is dimension of this vector? 1, 2, 3. 3 components we have, so its dimension is 3. Okay? Understood? So dimension is nothing but number of components in that vector, number of entries in that vector. Now come to the point. Classification of matrices. How to classify the matrices into different categories. Okay, before that I would like to write the given matrix A in compact form. What is compact form? The complete matrix A m cross n can be written like this: A I J m cross n, where 1 less than or equal to I less than or equal to m. Why? Because I varies from 1 to m. Sunny, it is too early to talk about eigenvalues in the first lecture. Okay? N 1 less than or equal to j less than or equal to n. So here I is row position, j is column position. So row position, how many rows you have? M rows. That's why I varies from 1 to m. J refers column position. Column, how many columns you have? N columns. That's why J varies from 1 to n. Okay? That's why in compact form, m cross n matrix can be written as Aij m cross n. I varies from 1 to m, J varies from 1 to n. Now, Classification of matrices. Different types of matrices. Mukherjee, vector has magnitude with direction. If we talk about the vector now, we are moving in another direction. Okay, what is required to the concept, I am going to explain that manner. You wait. Okay, now types of matrices. We have different types of matrices based on number of rows and the number of columns, based on M and N. Suppose if a matrix having only one row, it is known as row matrix. For example, matrix A is equal to 1 cross 4, 3, 2, 1, 5. 1 row, 4 columns. A matrix having only one row is known as row matrix. Next, column matrix. A matrix having only one column. A matrix having only one column is known as column matrix. For example, 3, 2, 1, 5. You have 4 rows, one and only one column. Okay. A matrix having only one column is known as column matrix. A matrix having only one row is known as row matrix. Next, rectangular matrix. Rectangular matrix. In a matrix, if the number of rows not equal to number of columns, number of rows not equal to number of columns, in a matrix, if the number of rows not equal to number of columns, then it is known as rectangular matrix. For example, 1, 3, 5, 2, 9, 7, 2 rows, 3 columns. 2 rows and 3 columns. It is 2 cross 3 matrix. Right? Understood? Now, square matrix. In a matrix, if the number of rows equal to number of columns, the number of rows equal to number of columns, then it is known as square matrix. For example, matrix A 2 3 5 9 2 cross 2. Chandu, row matrix, column matrix, both are rectangular matrix. Number of rows and number of columns are different, na? Just you read the definition. Whenever you get confused, just read the definition. Two, three, five, 1, 6, 9, 2 minus 1, 5, 3 cross 3 matrix. Okay. So number of rows equal to number of columns, then the matrix is known as square matrix. Number of rows equal to number of columns, then the matrix is known as square matrix. Okay. Based on number of rows and number of columns. Mr. Saini, if the matrix having only one element, matlab one row and one column, na? One row and one column is not square. Number of rows and number of columns are equal, na? Next, null matrix. Null matrix or zero matrix. Each element of the matrix is zero. Each element of the matrix is zero. Then it is known as null matrix. For example, 0, 0, 0, 0, 2 cross 2 null matrix. Generally, null matrix is represented by O. Okay. Zero, 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 zero. This is rectangular matrix, null matrix. Whether the matrix is either square matrix or rectangular matrix, every element of the matrix is zero, it is known as null matrix. Mohammed, what about 0 cross 0? No rows, no columns. No rows, no columns. Next. Yeah, principal diagonal. Manoj, I'll explain what is required. When it is required, I'll explain at the time. Okay? Concentrate on the content. If you have any innovative thoughts, you can ask me later. That is innovative thought. Chandan, if no values, how to write null matrix? This type of innovative thoughts you can ask me at 11:30. That is the right time to answer these type of questions. Okay? Now, concentrate. Principal diagonal. Principal diagonal. Generally, in a square matrix, you will have two types of diagonals. One is principal diagonal, another one is dummy diagonal. Which diagonal is called principal diagonal? In a square matrix, in a square matrix, the diagonal which consisting the elements A11, A22, A33 and so on, ANN is known as principal diagonal. The diagonal which consisting the entries A11, A22, A33 and so on, ANN, because it is a square matrix. I have mentioned clearly. In a square matrix, Aij, I equal to j, Mr. TR, I equal to j, that entry is known as principal diagonal entry. Okay. Now, for example, Abhishek, you need not to ask that type of question, because I have mentioned square matrix, you are mentioned rectangular matrix. Okay. The definition satisfies only when matrix is square. Now, A 395 minus 162 03 12. For example, the diagonal which consisting the entries A11, first row, first column, second row, second column, third row, third column, this diagonal is known as principal diagonal. This diagonal is known as principal diagonal. Yes, Suman, very good. Leading diagonal, principal diagonal or leading diagonal. Understood? There is another diagonal in the matrix that is called dummy diagonal. This is dummy diagonal. Now, our discussion is about principal diagonal. Okay. Avadesh, that is not off diagonal, that is dummy diagonal. Off diagonals are different. Off diagonal matlab matrix A 395 minus 162 0312. This is the matrix. In this matrix, this is principal diagonal. Our remaining entries 9, 5, 2, minus 1, 0, 3. These are called off diagonal elements. Okay. Remaining entries are known as off diagonal entries. So we are not talking about off diagonal. We are talking about only principal diagonal. Okay. Now, based on principal diagonal, we can classify the matrices into different categories. Okay. Now, observe. Triangular matrix, lower triangular matrix, lower triangular matrix. In a square matrix, if all the elements above the principal diagonal are 0, above the principal diagonal are 0, that is known as lower triangular matrix. For example, matrix A 1 0 0 2 3 0 5 6 9. All the elements above the principal diagonal are 0. That's why it is known as lower triangular matrix. What about upper triangular matrix? Reverse. Here above 0. Okay. Lower triangular means below the leading diagonal elements are 0. Understand? Upper triangular matrix. In a square matrix, if all the elements below the principal diagonal elements are 0, if all the elements below the leading diagonal are 0, then it is known as upper triangular matrix. Two, 5, 7, 0, 6, 9, 0, 0, 8. All the elements below the principal diagonal elements are 0. That's why it is upper triangular matrix. Understand? Mr. Saurabh, understand the definition properly. I said all the elements below the principal diagonal 0. If you have to check only these three entries. Okay. You need not to think about, sir, what is this entry? This entry always should be 5, always should be 7. That is unnecessary matter. So you have to concentrate on only on this point, not on the comment box. Okay. Similarly, here you have to concentrate on all the elements below the leading diagonal elements are 0 or not. Only these three entries. Whether these three entries are 0, you can say that it is upper triangular. Okay. Now concentrate. Next one, diagonal matrix. Diagonal matrix. Diagonal matrix means you can say a matrix which is both upper triangular and lower triangular. Okay, both upper triangular and lower triangular is known as diagonal matrix. It means all the elements above 0 as well as below 0 in a square matrix. In a square matrix, if all the off diagonal elements are 0, off diagonal elements are 0, then it is known as diagonal matrix. For example, 2 0 0 0 9 0 0 0 7. It is clearly all the elements above the principal diagonal are 0 and below the principal diagonal are 0. Okay. One point I have to clarify here. Some students have innovative thoughts. Sir, for example, the matrix is in the form of like this. B, matrix B is a 3 cross 3 matrix. 1 5 0 0 0 0 0 0 0 0. Sir, is it diagonal matrix or not? You have to check only off diagonal elements. Okay, this is principal diagonal. We are not interested about principal diagonal entries. We are interested about only off diagonal entries. So off diagonal entries are all 0 or not? 0. Therefore, it is diagonal matrix. Understood? So both above 0 and below 0, that is diagonal matrix. Understood? Next. Sachin, null matrix is always diagonal, or you can say symmetric, or you can say skew symmetric. You should not take null matrix as an example. Observe here. If all of diagonal elements of a matrix are 0, you can treat as diagonal matrix. Okay. Rohit, singleton matrix, how you are going to compare? Where you have the principal diagonal in singleton? Huh? Where is above element? Where is below element? Nothing, na? Square matrix is necessary because you require principal diagonal above 0, below 0. That is called diagonal. Both above 0 and both below 0. Below the leading diagonal elements are 0 and above the leading diagonal elements are 0. And sir, what is triangular matrix? Triangular means either upper triangular or lower triangular. Both are triangular matrices. Okay. Next. अवधेश सिंगलटन मैट्रिक्स में सिंगल एलिमेंट मैट्रिक्स. ये भी क्वेश्चन है क्या? 1x1. A matrix is both lower triangular, both lower triangular and upper triangular means सर ये triangular होगा नहीं होगा? पक्का होगा ना? Next one. Next one, scalar matrix. Scalar matrix. Scalar matrix means in a diagonal matrix. In a diagonal matrix, I mentioned in a diagonal matrix, all the leading diagonal elements are same. All the leading diagonal elements are same. In a diagonal matrix, if all the leading diagonal elements are same, then it is known as scalar matrix. For example, matrix is 5 0 0 0 5 0 0 0 5. It is a scalar matrix. Yeah, including identity matrix, Girisha. Principal diagonal elements are 1 in identity matrix. Therefore, that is scalar, 100%. Okay. So, every scalar matrix can be written as scalar multiplication of identity matrix. Scalar multiplication of identity matrix. That's my point. Now, next. Identity matrix or unit matrix. Previous slide. Okay. Because Now, identity matrix or unit matrix. In a diagonal matrix, if all the leading diagonal elements are same, if all the leading diagonal elements are unity, all the leading diagonal elements are unity, all the leading diagonal elements are unity, then it is known as identity matrix. It is represented by I. 1 0 0 0 1 0 0 0 1. This is known as I3. In a diagonal matrix, if all the leading diagonal elements are unity, it is known as identity. Prajat, scalar is not unity. Unit matrix is scalar matrix. Every scalar matrix is not unit matrix. Please remember. Okay. Identity matrix is scalar, but every scalar is not identity. Every scalar matrix can be written as scalar multiplication of identity matrix. Shubham, your question is, first you think about your question. Sir, diagonal matrix is a square matrix. So what is definition of diagonal matrix? In a square matrix. Okay. Identity matrix is always denoted by I. Its order is 3 cross 3. Then we are represented by I3. Okay. If it is 2 cross 2, 1 0 0 1, it is represented by I2. Based on that, we can understand identity matrix is of which order. Not all the elements are 1. Pile, Kya principal diagonal elements are 1, I said. You are talking about all the elements are 1. Huh? Observe here. Operations on matrices. Transpose of a matrix. Based on transpose of a matrix, Purushottam, I am going to solve all previous gate questions. I have given whatever problems I am going to discuss in this class, in this file. Okay? You can download the file. You don't worry about that. That is my job. You don't have any doubt, even 1%. Okay? Confidently, you can follow the course. Don't worry about that. कहां से डाउनलोड करेंगे? इधर से डाउनलोड करना, कब? क्लास होने के बाद डाउनलोड कर सकते हैं आपने. ओके, concentrate. Now, transpose of a matrix. Transpose of a matrix. So, transpose of a matrix is nothing but just interchanging rows into columns. Okay? Transpose of a matrix is nothing but interchanging of rows into columns. Okay? The transpose of a matrix is denoted by A transpose and is obtained by interchanging of rows into columns. If you interchange rows into columns, automatically you can get transpose. For example, A is 2, 3, 5, 6, 9, 8, 2 cross 3 matrix. Compulsory A transpose would be 3 cross 2 because you are interchanging rows into columns. Observe 2, 3, 5. First row you have written as first column. Second row you have to write as second column. Then automatically you got transpose of the matrix. So the transpose of the matrix is obtained by interchanging of rows into columns. First row you have to write as first column, second row you have to write as second column. Understood? Now, properties. A transpose whole transpose is always A. Understood? A transpose whole transpose equal to A. A plus B whole transpose equal to A transpose plus B transpose. Master, it is not incompetent man, idempotent matrix. Idempotent matrix is A square equal to A. Wait, let me classify. AB whole transpose equal to B transpose multiplied with A transpose. AB whole transpose equal to B transpose into A transpose. Okay. Previous slide is transpose. Yeah, definitely, Ritik. ABC whole transpose is C transpose, B transpose, A transpose. Okay. Now, Mukul, ES syllabus is covered. GATE syllabus is also covered. Okay. Only the thing is you have to concentrate on the class. Now, observe. Based on transpose operation, we can classify the matrices into again 3 categories. One is symmetric matrix. Symmetric matrix. A square matrix A is said to be symmetric. If A transpose equal to A transpose equal to A. For example, 19562 here 8. Observe. Just look at first row and first column. First row and first column are same. Second row and second column are same. Third row and third column are same. So simply you can say that is Aij equal to Aj for all Ij. This is symbol for all. Okay. for all ij. First row, second column, and second row, first column are same. First row, third column, and third row, first column are same. Second row, third column, and third row, second column entries are same. Okay. First row, second column, second row, first column entries are same. First row, third column, third row, first column, second row, third column, and third row, second column. That's why Aij equal to Aji for all Ij. Okay. That is known as symmetric matrix. Vivek, condition is only for Aij equal to Aji. Sir, what about diagonal matrix, diagonal entries? I refers row, J refers column. I refers row, J refers column. Okay? Row means row position. J represents J, column position. Now, skew symmetric matrix. Skew symmetric matrix. A square matrix A is said to be skew symmetric if A transpose equal to minus A transpose equal to minus A, that is Aij equal to minus Aj for all Ij. Okay. A square matrix A is said to be skew symmetric matrix if A transpose equal to minus A, that is Aij equal to minus Aj for all Ij. One point I have to recall in the case of skew symmetry. You have to remember this point. Note. Principal diagonal entries of principal diagonal elements of skew symmetric matrix are always 0. Are always 0. The principal diagonal elements of skew symmetric matrix are always 0. For example, matrix A 0, 0, 0, principal diagonal elements are 0. Now -1, -2, 1, 2, -3, 3. Sir, why principal diagonal entries are 0? Vishal, Aij equal to minus Aj. If you look at principal diagonal, in the principal diagonal entries are A11, A22, A33. A11 equal to minus A11. A value, a positive value and negative value both are equal for which real number? Only for 0. That's why compulsory principal diagonal elements must be 0. Understood? 0 and minus 0 both are equal. That's why compulsory you have to take principal diagonal entries are 0. Otherwise, you can't generate a skew symmetric matrix. Principal diagonal entries are 0. Sir, what about remaining entries? Clearly, they satisfy Aij equal to minus Aj because first row, second column is -1. Second row, first column is 1. First row, third column is -2. Second row, first row, third column is -2. Third row, first column is +2. AI is a minus AJ. First row, third column is second row, third column is -3. Third row, second column is +3. Understood? Always they must say, I have mentioned always. Always matlab 100%. Okay, you need not ask again, sir, always 0. I have mentioned always 0. Right. Next, there is one theorem based on symmetric and skew symmetry. Every square matrix can be expressed as the sum of symmetric and skew symmetric matrices. Every square matrix can be expressed as the sum of symmetric and skew symmetric matrices. That is, A is equal to A plus A transpose by 2 plus A minus A transpose by 2. Yeah, I'll explain. This is always symmetric. This is always skew symmetric. Sir, why it is so? I'll give the example. Every square matrix can be expressed as sum of symmetric and skew symmetric matrices. For example, A, you can take any entries. Please take non-zero entries. Okay. 2, 5, 3, 9, for example. Sumant, I have taken 2 cross 2 matrix. 2 cross 2 matrix में 9 elements you should not fit. You can fit only 4 entries. Okay? Now A transpose. Same matrix you have to transpose. Okay? So 2, 3, 5, 9. Same means you have to write row elements as column elements. So interchanging of rows into columns. We got A transpose. Now I have to prove that A plus A transpose by 2 is symmetry. That's why I am adding both. A plus A transpose by 2. So 1 by 2 of A plus A transpose. I hope you all know about matrix addition. Matrix addition is nothing but adding corresponding entries. 2 plus 2, 4. 5 plus 3, 8. 3 plus 5, 8. 9 plus 9, 18. Now observe. 1 by 2 of 4, 8, 8, 18 is nothing but 4 by 2 is 2, 8 by 2 is 4, 4, 9. Now tell me, Trinetra Kumar, A plus A transpose by 2 is symmetric. I have to prove that. Sir, why by 2? I have written by 2 here. Otherwise, LHS and RHS are not same. Now, 2449 is symmetric or not? Sir, what is symmetric? A transpose must be equal to A. the Aij and Aji are same, therefore it is symmetric. Okay, A plus A transpose by 2 is symmetric. I have to prove that A plus A transpose by 2 is symmetric, and we got A plus A transpose by 2 is symmetric. Now I have to prove that A minus A transpose by 2 is always Q symmetric. That's why I am going to find A minus A transpose by 2. 1 by 2 of A minus A transpose. Subtract corresponding entries in A and A transpose. 2 minus 2 corresponding entries. 2 minus 2 0. 5 minus 3 2. 3 minus 5 minus 2. 9 minus 9 0. Now 1 by 2 of 0 2 minus 2 0 means if you write 0 by 2 is 0, 2 by 2 is 1, minus 2 by 2 is minus 1, 0 by 2 is 0. Now 0 1 minus 1 0. First you have to verify principal diagonal entries are 0 or not. Clearly principal diagonal entries are 0. Next you verify the remaining entries are satisfying Aij equal to minus Aj or not. Clearly 1 and minus 1. Therefore it is Q symmetry. Therefore we can understand that A minus A transpose by 2 is always skew symmetric. Understood? Now, orthogonal matrix. When we say a matrix is orthogonal matrix, next one. The basic definition of orthogonal matrix is orthogonal matrix is A into A transpose equal to I. A square matrix A is said to be orthogonal matrix if A into A transpose equal to A transpose into A is equal to I. Okay. A square matrix A is said to be orthogonal matrix if A into A transpose equal to A transpose into A is equal to I. This is the basic definition. But beautiful results we have on orthogonal matrix. I'll explain one by one. Simple 2 cross 2 matrix I am taking. Cos theta, sin theta, minus sin theta, cos theta. For all values of theta. For all values of theta means theta varying from 0 to 2 pi. Cos theta, sin theta, minus sin theta, cos theta is a standard orthogonal matrix. Okay. If you calculate A into A transpose, definitely you will get identity matrix I. A multiplied with A transpose, cos theta, sin theta, minus sin theta, cos theta. If I take transpose, I will get here cos theta minus sin theta cos theta. Multiply. You know matrix multiplication, right? Product of two matrices. Generally, matrix multiplication is row with column, not corresponding entries. Row multiplied with column. First row multiplied with first column gives one element. Cos square theta plus sin square theta. Next. First row with second column. Cos theta into minus sin theta minus cos theta sin theta plus sin theta cos theta. Here minus sin theta cos theta plus cos theta sin theta. Next, second row with second column. Sin square theta plus cos square theta. That is nothing but 1 0 0 1. That is identity matrix. A into A transpose equal to identity matrix or not? So clearly A into A transpose equal to I. Understood? So matrix multiplication is row with column. First row with first column, 1 element. First row with second column, 1 2 element. Second row with first column, 2 1 element. Second row with second column, 2 2 element. So same orthogonal matrix. Based on orthogonal matrix, I can give some conclusions. Okay. Before going to that conclusions, first I have to explain what is orthogonal vector and what is orthonormal vector. Okay. Let me explain those points. Concentrate here. Orthogonal vector. Orthonormal vector. Concentrate here. Sir, when two vectors are said to be orthogonal vectors, when two vectors are said to be orthonormal vectors. Suppose x1 and x2. x1 and x2 are said to be orthogonal vectors if x1 transpose dot x2 equal to 0. Dot product between two vectors are 0. Sir, what about orthonormal vectors? x1 and x2 are said to be orthonormal vectors if first condition x1 transpose dot x2 must be 0. Second condition, length of x1 must be 1, length of x2 must be 1. So not only orthogonality condition but also unit length. Length must be unity. Length of each vector must be 1. That is additional condition of orthonormal. Now my question is, sir, orthonormal vectors are said to be orthogonal? Orthonormal vectors are said to be orthogonal or not? 100%. Orthonormal is always orthogonal, but converse need not be true. Orthonormal vectors are always orthogonal vectors. Orthonormal are always orthogonal, but converse need not be true. Need not be true. Converse need not be true. I never said wrong. Need not be true. Maybe or may not be. It is not compulsory. It is not necessary. But orthonormal vectors are always orthogonal vectors. Mayank, please understand length of the vector, not length of matrix. You cannot find length of matrix. You can find length of vector. Okay? Vector matlab one row or one column. Not 2 cross 2 matrix or 10 cross 10 matrix. Length of a vector. I'll explain. Wait. Observe here. For example, x1 is 1 minus 1. x2 is 1, 1. Sir, whether these two vectors are orthogonal vectors or orthonormal vectors, we are verifying. Mukul, what is physical significance of matrix? So many physical significances we have. Suppose you went to some airport, flight data is given with respect to timings. What is the table they are going to follow? Matrix table. Railway timetable follows matrix table. Sir, what is physical significance of matrix? Everywhere you can use matrix. Your comment box is also following matrix. Okay. One column, how many rows? How many number of students are commenting on the comment box? That number of rows. Okay. Now come here. Observe. X1 and X2. Don't divert the concept. Please concentrate. So what are orthogonal and what are orthonormal? Now observe. X1 transpose dot X2 minus 1, 1, 1, 1. If you multiply, row multiplied with column, what it gives? Minus 1 into 1, minus 1, plus 1 into 1, 1, minus 1 plus 1, 0. Dot product is 0. So clearly first condition is satisfied. Okay. Now, if you calculate, Mr. Aspirant, I am talking about orthogonal and orthonormal only. What is mod x1? Calculate. Square root of 1 square plus minus 1 whole square. Okay. Square root of 1 plus 1. That is root 2. What is length? What is length? Okay. Now, magnitude is root 2. Magnitude is not 1. Magnitude is not 1. Therefore, x1 and x2 are orthonormal or orthogonal? Which one? Orthogonal vectors. They are satisfying only orthogonality condition, not orthonormal condition. Catch my point? Therefore, x1 and x2 are orthogonal vectors. Don't get confused. Orthogonal matrix is different. Orthogonal vectors are different. Orthogonal matrix is different. Orthogonal vectors are different. Now we are talking about orthogonal vectors. Orthogonal vectors matlab perpendicular vectors. Perpendicular vectors. Their inner product is 0. Orthonormal vectors means not only orthogonality, but also length of each vector is 1. Sir, now what about orthogonal matrix? Now I am talking about orthogonal matrix. Nandini, always you have to take inner product. Inner product matlab dot product between two vectors must give a scalar quantity. Okay, sir, why I should not take x1 into x2 transpose? If you take x2 transpose, what will come? That is 2 cross 1, that is 1 cross 2. 2 cross 2 will come. 2 cross 2 is not a scalar quantity. Okay, always you have to write comfortable for multiplication model. How do we know that which one is should be transposed? Means it is just common sense, simple logic. If you take 2 cross 1, if you multiply x2 transpose 1 cross 2, 2 cross 1 with 1 cross 2, 2 cross 2 will come. 2 cross 2 is not inner product na? Okay, now come to the problem. Orthogonal matrix. I told you some special properties we have in the case of orthogonal matrix. Shubham, you can transpose like that. Comfortable for multiplication, the inner product must be scalar quantity. Okay? Mahinder, observe here. Orthonormal means not only perpendicular, but also length of each vector must be 1. Okay? Now come to the matrix, orthogonal matrix. Observe. Orthogonal matrix is nothing but A into A transpose equal to I. That is basic definition. I am giving additional definition. What is that? If your matrix is orthogonal matrix, 100% your matrix is combination of orthonormal vectors. Please observe. Orthonormal vectors. I am explaining matrix format only. Please concentrate. Orthogonal matrix. I said A is orthogonal matrix. I have proved that A is orthogonal matrix because A into A transpose equal to I. Okay. Now I am giving additional property. If your matrix is orthogonal matrix, suppose A 2 cross 2 is orthogonal matrix, then compulsory R1 and R2 are orthonormal vectors. Immediately one student will question, sir, why you have written only R1 and R2 are orthonormal vectors? Why not C1 and C2? C1 and C2 also. Any property which is applicable for rows, that is applicable for columns also. C1 and C2 are orthonormal vectors. If your matrix is orthogonal matrix, I am talking about orthogonal matrix, whether it is 3 cross 3 or 10 cross 10, a property is applicable means it is applicable for n cross n also. Now come here. This is clearly orthogonal matrix. Now you verify whether the vectors are orthonormal or not. Okay, concentrate. Matrix A is cos theta sin theta minus sin theta cos theta. Now you take two row vectors R1. R1 is cos theta sin theta. R2 is minus sin theta cos theta. 1 minute, observe here. This is 1 cross 2 format. This is 1 cross 2 format. How to get 1 cross 1? 1 cross 1. How to get 1 cross 1? If you multiply 2 cross 1 with 1 cross 2, then you will get 1 cross 1. Catch my point? So you have to write R1 into R2 transpose. Okay. Otherwise, R2 multiplied with R1 transpose, you can write in that manner also. Because A bar dot B bar and B bar dot A bar both are same, na? That's why. Now concentrate. But the dot product must give a unique value, that is nothing but 1 cross 1 value. Okay. Now R1 cos theta sin theta dot product with minus sin theta cos theta. What is the value? Multiply cos theta sin theta minus plus sin theta cos theta. Are you getting 0 or not? Okay. Suppose if you calculate length of R1, what is mod of R1? Square root of cos square theta plus sin square theta, that is 1. Modulus of R2, square root of sin square theta plus cos square theta, 1. So the conclusion is, if your matrix is orthogonal matrix, 100% row vectors as well as column vectors are orthonormal. Whether your matrix is 2 cross 2 or 10 cross 10. Catch my point? Prudvi, Pardev, Rawat, AB is always equal to B ana. कौन बोला आपको? In matrix theory, AB is not equal to BA in general. You need not to test me. I am not a new faculty. Okay? All innovative questions. Come here. Did you understand what is orthogonal matrix and what are the specialities of orthogonal matrix? Especially if you would like to check A into A transpose equal to I, 9 elements you have to create for 3 cross 3 matrix. Consumes time. That's why better to follow this property. Orthogonal matrix is combination of orthogonal vectors, orthonormal vectors. Okay? By using length 1 and by using inner product 0, you can solve the problem very easily. Length, mod, norm, all are same. Devanshu, length, mod, norm, all are same. Sachin, if the matrix is 3 cross 3, R1, R2, R2, R3, R3, R1 are orthonormal. Okay? Mod, length, norm, all are same. Now, come to the problem. Observe this problem. First read the problem. Matrix A, Aij. Sunil, orthogonal vectors are formed by orthogonal vectors are. क्या पूछ रहे हैं जी? Orthogonal vectors are formed by orthogonal vectors क्या जी? Orthogonal matrices are. Orthogonal matrices are formed by orthonormal vectors. Right? Correct the statement. Orthogonal matrices are formed by orthonormal vectors. Now, observe the problem. matrix A M cross N is defined as Aij equal to Mukul. I am writing orthogonal matrices are formed by orthonormal vectors. A property is applicable for rows means the property is applicable for columns also. I have mentioned clearly here R1, R2, C1, C2 within bracket. I am writing the notes clearly. You can download the copy. Okay. Instead of writing the notes, concentrate on the content, explanation. If you understand the concept, you can get very easily. Now, in this problem, matrix A is defined as, you can post your answers. I'll conduct the poll. Okay, you need not to post it on the comment box. Okay, you follow that. Matrix A is defined as Aij M cross N, where Aij equal to I plus j for all Ij. Then sum of all elements of A. Sum of all elements of A. There are two methods to solve this problem. One method is using options. Another method is conventional approach. Observe. Suppose your matrix is 2 cross 3. Aij equal to I plus j for all Ij. They have provided. I am explaining morally. A11, A12, A13, A21, A22, A23. Every entry satisfies the condition Aij equal to I plus j. Okay. Now observe. 1, 1. I plus j. I plus j. Okay. 1, 1 matlab 1 plus 1, 2. 1, 2. 1, 2 means 1 plus 2, 3. 1, 3. 1 plus 3, 4. 2, 1. 2 plus 1, 3. 2, 2. 2 plus 2, 4. 2, 3. 2 plus 3, 5. Sum of all elements. Sum of all elements equal to 2 plus 3 plus 4 plus 3 plus 4 plus 5. What is the sum? 5 plus 4, 9. 9 plus 7, 9 plus 7, 16. 16 plus 5, 21. Your matrix is 2 cross 3 matrix. So if you compare with M cross N, if you compare with M cross N, what is M value? 2 na? N value 3 na? So if you put M equal to 2, N equal to 3, M equal to 2, N equal to 3 in the options, Bharadwaj, they have given M cross N. That's why I have taken rectangular matrix. Suppose if they would give N cross N, I would take both are equal. Okay. Now come here. Come to the point. M is 2, N is 3. If I put M is 2, N is 3 in options, M is 2, N is 3. 2, 3 is 6. 6 by 2 of 2 plus 3 plus 1. What is that? 2 plus 3 plus 1 is 6. 6, 3 is 18. But your answer is 21. That's why this is incorrect. Now come here. 2 into 3 by 2 of 2 plus 3 plus 2. Now 2 cancel. 2 cancel. 3 7 ja 21. So 21 satisfied. Okay, that's why second option is correct by verification. That is first method. That is first method. Murali, understood? Now I am explaining second method. 2 cross 3 लेने हैं तो 3 cross 2 भी ले सकते, 10 cross 5 भी ले सकते. Only to reduce our calculation work, I have taken 2 cross 3. Okay. Sir, how can we write A is A equal to A plus I plus J na? Digesh, we are not going to write, Baba. They have given. Whatever they have given, we have to take. Now, Murali, don't worry. Observe, I am explaining conventional approach also. In this problem, systematically, if you add, you can get the answer very easily. M cross N. Okay. A11, A12, A1N, A21, A22, A2N, AM1, AM2, AMN. That is given in the data. Bharadwaj, it is lengthy, no problem, but you can understand one logic. Counting technique, you can understand. Okay, concentrate. Observe, Aij equal to I plus J for all Ij. That is not my assumption, that is given in the data. Okay, now I plus J matlab 1 plus 1, 1 plus 2, 1 plus M, 2 plus 1, 2 plus 2, 2 plus M, M plus 1, M plus 2, M plus N. Sir, why you have taken 1 plus 1? 1 plus 1 is 2, everyone knows, but I have not written because purposefully. Concentrate. I am going to add first row. Next I am going to add second row. Next I am going to add mth row. Observe how I am going to add 1, 1, 1. How many ones? How many one? How many columns you have? That number of ones. So n into 1, because n columns you have. So n into 1. Second row, 2, 2, 2. How many 2? N number of 2 times. N times. 2 is n times. Next, last row, m, m, m. How many times? N times. Okay. Mn times. M is n times. Plus, plus, plus. Second entry. Observe, 1 plus 2 plus 3 plus n. N into n plus 1 by 2. Next, 1 plus 2 plus n. N into n plus 1 by 2. Last row, 1 plus 2 plus and so on n. n into n plus 1 by 2. Now we have to add first one, second one, and mth one. Add. Okay. This is n number of m's na. N number of m's. So n you take common. 1 plus 2 plus 3 plus and so on m. M into m plus 1 by 2. Here, how many number of n into n plus 1 by 2? M number. N into n plus 1 by 2. You take mn by 2 common in both. You will get m plus 1 here, n plus 1 here. So mn by 2 of m plus n plus 2. Mn by 2 of m plus n plus 2. That's why second option is correct. We can understand the procedure. What is the procedure? Counting procedure. Okay. Next. This is second method. Bharadwaj, if you understand second method, you can understand the entire process. In examination point of view, time. Okay, you can save time by applying first method. Murali, only by practice you can improve your mathematics. You don't worry. First you have to enjoy the subject. Next problem. Let A be a 3 cross 3 matrix. Let A be a 3 cross 3 matrix. A into 2 minus 1 0 is 2 minus 1 0. A into minus 1 2 minus 1 is minus 2 4 minus 2. A into 0 minus 1 2 is 0 minus 3 6. Q is provided. Then AQ. Our job is to calculate AQ. If you understand the logic, you can get the answer in less than 1 minute. Otherwise, it will trouble you. Minimum 20 minutes. Main thing is you have to understand matrix multiplication logic here. Very good. Now I am explaining the logic. Here, matrix A multiplied with matrix Q. The result is AQ. Okay. Now, A is 3 cross 3 matrix. Q is 3 cross 3 matrix. Result is also a 3 cross 3 matrix. Here, Q is known. This is known. A is unknown. AQ is unknown. Unknown. So A is unknown. AQ is also unknown. Only Q is known. How to calculate AQ? Yeah, to calculate AQ, some hints he has provided in the data. Okay. Now observe. Whether yourself or myself, whenever we are multiplying two matrices, we have one practice. What is our practice? first row multiplied with first column, 1 element. We are going to fill. Next, our practice is first row multiplied with second column. We are going to write 1/2 element. That is our practice. Understood? Got it? Now the problem is not designed on this practice. The problem is designed on another practice. Observe here. First row of A multiplied with first column of Q, the result is 1/1 element. Second row of A multiplied with first column of Q, second multiplied with first, 2/1 element. Third row multiplied with first column, first row multiplied with first column 1/1, second row multiplied with first column 2/1, third row multiplied with first column 3/1. So you are getting completely first column elements. So you can understand one logic here. First row of A multiplied with first column of Q. First column of Q, 1 minute. C1 of Q. First row, first, second row, third row. First row, third row, first row, second row, third row. मतलब matrix ये ना, complete matrix ना. First row, second row, third row. Matrix consisting only 3 rows, 3 columns. Okay. So first row, second row, third row means complete matrix A. Matrix A multiplied with first column of Q, the result is first column of AQ. Chaudhary, A is not given, man. That's why we are unknown. Okay, unknown matlab we don't know. They have not provided in the data. Okay. Now matrix A multiplied with first column of Q, result is first column of AQ. Sir, matrix A multiplied with second column of Q, what is the result? Matrix A multiplied with second column of Q, I mean first with second, second with second, third with second, you are going to get second column of AQ or not? C2 of AQ or not? Okay. Now observe. In the data, it is given that. In the data, it is given that. Concentrate here, please. Matrix A. Matrix A multiplied with 2 minus 1 0. Result is 2 minus 1 0. Sir, where is 2 minus 1 0? In Q, first column na? This is nothing but first column of Q na? C1 of Q na? So matrix A multiplied with C1 of Q, what would be the result? C1 of AQ. Understood? Understood? So 2 minus 1 0 must be first column of AQ. First column of AQ. So look at the options. Look at the options. In which option you have first column is 2 minus 1 0. So third option is correct. Okay. Next level. Observe. Next level. Very simple. Next, second hint he has provided in the data. What is that? Matrix A multiplied with -1, 2, -1. Sir, where is -1, 2, -1? Second column, na? Second column of Q or not? So C2 of Q. So matrix A multiplied with C2 of Q, result must be C2 of AQ. Verify C2 in third option. -2, 4, -2 or not? You have -2, 4, -2 or not? Similarly, third hint, matrix A multiplied with 0, -1, 2. 0, -1, 2 is third column of A, third column of Q, na? So third column of Q is 0, -1, 2. Therefore, the result 0, -3, 6. Look at the third column, 0, -3, 6 or not. So entire matrix AQ, you found that with the help of given hints. Understood? So problem is designed on simple matrix multiplication. Next problem. This is also a problem designed on matrix multiplication. Observe. A is M cross M. B is N cross P. The number of multiplicative operations. The number of multiplicative operations and additive operations needed to calculate matrix AB. Needed to be calculate matrix AB respectively. Okay. Classes कितने hours चले गए? Every day 2 hours. Total 58 or 59 lectures. 57 or 58. So almost all 116 hours. Okay. Entire course will be covered. It is not possible to change the timings. Course is already published. Okay, it is completely ideal time, common to all the branches. Now observe the problem. Matrix is M cross N, B is N cross P. The number of multiplicative operations and additive operations needed to calculate matrix AB, to generate matrix AB, to create matrix AB. How many number of times you have applied multiplication and how many number of times you have applied additive operation? Very good. Observe. Murali, you can, no problem. Observe. Matrix A, M cross N. Matrix B, N cross P. Matrix AB. M cross N multiplied with N cross P, compulsory M cross P, right? m cross n multiplied with m cross p, n cross p, result would be m cross p, mp. Okay, now I am multiplying, I am not multiplying m rows and columns, nothing. Only one row multiplied with one column. I am going to count operations. Observe the logic. A11, A12, A1n. Only one row I have taken. Now one column. B11, B21, Bn1. One column. Now multiply. First row multiplied with first column, I will get one element. What to create one element? How many times I have multiplied? I am going to count. How many times I have added? I am going to count. Okay, observe. A11 multiplied with B11. First time multiplied. Here multiplied. Plus A12 multiplied with B21. Second time multiplied, plus A1n multiplied with Bn1 multiplied nth time. First time, second time, nth time. So n times I have multiplied to create one element. Sir, how many times you have added? Count. Very simple. First time multiplied, first time added. Second time multiplied, second time added. Nth time multiplied. Did I added nth time? No. Only n minus 1th time I have added. First time multiplied, first time added. Second time multiplied, second time added. Nth time multiplied. After nth time I have not added nth time. Only I have added n minus 1th time. This is n minus 1. This is second. This is first. So n minus 1 times I have added to create one element. How many elements I have to create? MP elements na? MP elements na? So MP into n times I have to multiply. MP into n minus 1 times I have to add. So MPN multiplications and MPN minus 1 additions. Understood? Okay. Now you can ask me if you have any innovative thoughts. I have given the contact number here. Okay. You can send me the message. I will add you in the discussion group. I am maintaining only one group. In that group, you can ask any of your queries. Okay. Sometimes other students gives you the answers. If the students are giving any incorrect answer, I will act. Okay. Another thing, sir, how to follow? Very simple. You follow the regular course. We are going to cover almost all 800 problems. We are going to solve 800 problems. Okay. After that, another practice course which I have started from March 1st onwards. In that 640 problems, I have published the book. Only problems. Last year, which I have given DPPs, all the daily practice problems combinedly, I have given one book. In that book, that is completely practice course. Okay. You can download the book from file section in the Telegram group. Yeah, you send me the message. I have given the number. I will add you in the group. So from that group, you can download from file section. Directly, the book is available. So in that book, 640 problems are there. That is for practice purpose. Already those problems I am discussing in practice course. Okay, that 640, this 800, almost all 1500 problems. There is no different varieties. All different varieties will be covered in these two courses. Okay, then PYQ sessions will start from June onwards. Yeah, for CSC students, you have to follow only 3 topics: calculus, linear algebra, and probability and statistics. Okay, discrete maths, I am going to start from May first week. In that, I am going to discuss 4 courses, 4 topics. All conventional, non-conventional problems we are discussing in the class. You don't worry about that. Ankit, there is only one class which is going on 9:30 p.m. to 11:30 p.m. There is no other batch in the morning. Okay, right now. Yeah, chemical engineering students, follow this course. It is sufficient. I am covering those problems also. Discrete mathematics after calculus, Nicha. Linear algebra and calculus, then discrete maths. Okay, right. Mohammed, first you attend regular course. In this problem, how I am proceeding, how I am processing the data, you observe keenly. Definitely you can able to solve new questions. Bakshi, logic, graph theory, and combinatorics, sets, relations, functions, and group theory. These are all comes under discrete maths. Trinetra, we are the teachers. We won't mind anything, right? Just attend the class. I told you, Pathak, graph theory, these are all for discrete mathematics, I said. Yeah, definitely Bharadwaj. Noted. You can use Shivam. Good night. Not whole engineering mathematics, algebra, calculus, and probability. Separate course. Thank you. Good night.